Every bridge you cross, every skyscraper you see, even the layout of our cities, it's all built by civil engineers. Incredible feats.
Absolutely. Monuments to ingenuity, like you said.
But what if those engineers had a new kind of partner? Something, well, hyper-intelligent. Today, we're going beyond the surface. We're doing a proper deep dive into artificial intelligence and how it's fundamentally changing civil engineering.
And it's not science fiction, is it? This is happening now.
Exactly. It's transforming infrastructure as we speak. For this deep dive, we've dug into, the latest research, real case studies.
Lots of data out there.
Loads. And our mission really is to pull out those key insights, maybe some surprising facts, to show you how AI is revolutionizing this field.
And it's such a ripe field for it. Civil engineering is inherently complex, it's massively data heavy, and it's all about making critical decisions.
Right, so AI fits right in.
Perfectly. The core idea, the promise, is to boost efficiency, really enhance safety, and drive sustainability. And that's across the board from the first design sketch to long-term maintenance.
Okay, so let's unpack that, thinking about building our world. Where does AI first really start making a mark?
Well, it really kicks off right at the very beginning, the initial phases, design and planning.
Okay.
Take design optimization. Traditionally, engineers might compare, a dozen options? Maybe.
They'd have time, yeah.
Right. But with AI-assisted BIM that's building information modeling and simulations, you can explore literally millions of possibilities in minutes.
Millions? How does that even work?
It often uses something called genetic algorithms. It's a type of AI that sort of mimics natural selection, It evolves the best design by testing countless variations against set criteria.
Wow. Evolving designs.
Yeah. Finding these incredible best fit designs. We've seen studies showing it can cut material waste by 15-20% and save millions on project costs.
All before construction even starts.
Exactly. Plus, AI tools can generate alternatives, optimize layouts, and maybe, crucially, catch compliance issues or design clashes really early. That saves huge headaches later.
I can imagine. What about things like understanding the ground itself, geotechnical stuff?
Another huge area. AI is getting very good at predicting soil properties using machine learning. It learns from massive amounts of data, borehole logs, lab tests.
Okay.
And it performs complex analyses like slope stability or predicting how much ground will settle under a structure. Again, faster and potentially more accurately than traditional methods alone.
And seismic analysis too, I suppose. Predicting earthquake impact.
Definitely.
Right.
AI-powered simulations are improving foundation design and, importantly, disaster preparedness. They can model how a structure will respond to an earthquake with a level of precision we just didn't have before.
It's genuinely, mind-boggling how it streamlines that whole upfront process. But okay, a great design is one thing. How does AI help keep these structures standing strong, performing well for decades? The long haul.
You're right. The build is just the start. That brings us to monitoring, maintenance, and what we call asset management.
Okay.
Think about structural health monitoring, or SHM. This isn't entirely new, but AI supercharges it. We use sensors, drones equipped with cameras, LiDAR.
Gathering tons of data.
Constantly. And then machine learning models analyze that data stream to detect tiny issues, microscopic cracks, subtle corrosion, weird vibrations, things a human eye would miss.
So it sees problems earlier.
Much earlier.
Yeah.
But it goes further. AI can actually predict potential failures in critical infrastructure, bridges, dams, big buildings, long before they become dangerous. It's moving from fixing things after they break to preventing breaks altogether.
Predictive intervention. That's a big shift.
It really is.
Yeah.
And tied into that is something really exciting. Digital twin technology.
Digital twins. I've heard that term. What does it mean here?
Essentially, it's creating a real-time, data-rich virtual replica of a physical asset. Imagine a perfect digital copy of a specific bridge, constantly updated with live data from sensors on the actual bridge.
Okay, like a living model.
Exactly. Engineers can then use this digital twin to simulate performance, what happens in high winds or under heavy load. They can test repair strategies virtually, predict failures within this safe digital space.
Optimize maintenance for the real bridge based on that.
Precisely. It informs predictive maintenance strategies. AI analyzes the condition data and helps prioritize repairs based on actual risk, not just on a fixed schedule. This means huge cost savings and obviously much better safety.
So AI gives these structures eyes, ears, and a kind of predictive brain. That's amazing for managing what we already have built.
It's a game changer for asset management, truly.
Let's zoom out a bit then. If it can monitor a single bridge so closely, how does AI impact, the bigger picture, whole city systems, urban environments?
Great question. On that broader scale, AI's impact is also profound. Take transportation and traffic engineering.
Oh yeah, traffic. Everyone feels that.
Right. We're seeing AI used for smart traffic signal control lights that adapt to actual traffic flow in real time, not just timers. Exactly. Also predicting accident hotspots based on historical data and real-time conditions. And it's paving the way for, eventually, fully autonomous traffic systems. The infrastructure itself learns and adapts.
Making commutes smoother, hopefully safer, maybe even greener?
Absolutely. Less idling, more efficient flow. And then there's water resource engineering. AI helps with complex modeling for rainfall runoff, flood forecasting.
Predicting floods more accurately.
Yeah, predicting where and when flooding might occur with greater lead time. It also optimizes how reservoirs are operated, balancing water supply, flood control, power generation, and it monitors water quality using networks of sensors.
Okay, water, traffic. What about the city itself? Planning.
That too. For smart cities and urban planning, AI analyzes satellite imagery for land use classification, helping planners understand how land is being used and how it's changing.
Right.
And it helps optimize citywide systems, energy grids, waste collection routes, integrating traffic flow management. It's all about making urban environments more efficient, more resilient, and ultimately more sustainable.
It's like giving the city a central nervous system.
That's a great way to put it. A nervous system and a brain, constantly learning and optimizing.
The sheer scope is, well, it's incredible. AI is touching almost every part of civil engineering, making things smarter, more predictive, more efficient, safer, greener, cheaper infrastructure.
That's the goal, yes.
But this brings up the big question, one probably on many of the listeners' minds. What about the human engineer? Is AI taking their jobs?
That's such a critical point, and honestly, the sources we looked at are pretty consistent on this. AI is seen as augmenting engineering, not replacing it.
Augmenting how?
Think of it like this. AI takes over the really repetitive data crunching tasks, the complex simulations, the optimization across millions of variables, the constant monitoring, stuff that's frankly tedious or impossible for humans to do at that scale and speed.
Grunt work, basically.
A lot of it, yeah. And that frees up the human engineers to focus on the higher level stuff. Complex problem solving, creative design thinking, ethical considerations, client communication, managing teams.
The things that need human judgment and innovation.
Exactly. AI is a powerful tool, maybe the most powerful tool engineers have ever had. It's like giving them a superpowered assistant, letting them achieve more, design better, and solve bigger problems.
So it elevates the role rather than eliminates it.
That seems to be the consensus. It changes the skill set needed, for sure, but the need for expert human oversight and ingenuity remains crucial.
Okay, that's reassuring and actually quite exciting. So wrapping this up, AI is clearly making infrastructure smarter, safer, more sustainable.
Definitely more efficient and predictive, too.
As AI keeps evolving, getting faster, learning from more data, maybe think about this. How will this shift continue to reshape not just our cities and bridges, but what it even means to be an engineer decades from now?
What are the next big challenges AI might help us solve? What new opportunities will emerge for our built environment, for the whole world around us? It's something to keep watching.
Indeed it is. Thank you for joining us on this deep dive.